Today is March 30th, 2015, and I am in the Senior Physiologist Lounge at the Boston Convention Center at the annual meeting for the American Physiological Society. And today it's my distinct pleasure and honor to be able to interview Dr. William Talman for the APS's Living History Project. Dr. Talman is a longstanding member of the American Physiological Society, for which he served as counselor and as the president of FASIB. He has been affiliated with the University of Iowa Department of Neurology for 33 years, where he has performed research that's focused on the physiology of central cardiovascular control. And among a number of scientific accomplishments or contributions, he has shown a vital role for astrocytes in control of blood pressure in the nucleus tractus solitarius. He's a clinical neurologist, specializes in autonomic control, and has been named one of America's best doctors for many years. And as a testament to his diverse interests, he also publishes blogs on science policy in the Huffington Post. Good afternoon, Bill.
Hi, George.
Welcome to the Living History Project, and thank you very much for agreeing to participate. I'd like to ask you a series of questions and find out more about your career and how it has evolved.
Thank you actually for agreeing to interview me. I appreciate it. If you don't mind, before we even get started, I just want to comment about how you ended up being in the same room with me. I don't even want to say how many years ago, and I know you don't want to say how many years ago, but we first met when you were a medical student, MD, PhD at Iowa. And I like to take a tiny, like 1 week's worth of credit for your training, because you spent about that amount of time with me on the wards, learning some neurology, and it's been an incredible pleasure. It always is for a teacher, watching a student with whom they've worked go on to the accomplishments that you have. So it's a double honor for me to have you do the interview. So thank you. I'll try to answer the questions. I don't know how well I'll do in addressing them, but I'll do as well as I can.
Maybe you can begin by telling us about your family upbringing and how that helped you to direct your career towards science.
Yeah, well, you know, thinking about that is, thinking about my own family, I grew up in a middle-class family in Richmond, Virginia. My father was a civil engineer. My mother was a housewife and mom, very devoted. Both of them were, as parents. I'm a brat. I have no siblings, okay? So I got a lot of attention from both parents, neither of whom was a scientist. In fact, there aren't any scientists in my family, in the direct family. I have an uncle who was sort of a scientist, a mine safety engineer who went on to the National Academy, but I hardly even knew that until after he'd passed away. But they revered science. They really thought a lot of science and scientists. They valued education. They wanted me to be inquisitive. They put a lot of stock in me as the only child. But they taught me that my ideas were valuable, but they were also fallible. And I think that taught me early on that the null hypothesis many times wins out over what we think is going on. So in a sense, I was being trained as a scientist by my non-scientific parents. And then after finishing my growing up with them, I went on and had more experiences that actually were scientific, but they were very valuable. They taught me what I think are incredibly important lessons for all of us in science to learn, and that's ethics and discipline and a code of conduct. And if we don't follow those, we sort of lose the public trust.
Undergraduate years.
Sure. Well, after doing my elementary and high school education in Richmond, I got a baccalaureate degree from the Virginia Military Institute, VMI, in Lexington. And I must say that if there was a code of conduct and honor that had been instilled at home, it was pushed even more at VMI. So by the time I graduated from VMI, if I hadn't been an honorable person, I wouldn't have gotten out of there. Hopefully I've maintained that. Anyhow, from VMI, where I met one of the people that I really consider influential, one of my mentors in biology, I went from VMI to the University of Virginia for medical school. And had opportunities at Virginia also to involve myself somewhat in science. met some people that were very influential in my life and in my career scientifically. And from Virginia, as a result of one of the people with whom I'd worked, actually two of the people with whom I'd worked, who had very strong ties in Cleveland and Case Western Reserve, I went to Case Western Reserve University to do my internal medicine residency. In those days, to get into neurology, you had to be board eligible in internal medicine. So I spent 2 years at Case, after which I went into the Army. Now, you might find it strange that I would mention the Army under academic experiences, but it was truly an educational experience. And it brought me in contact with another person that I could mention later that also was quite influential in developing my interest that ultimately became my scientific interest. From the Army, I went on to Cornell, and at Cornell University Medical College under Fred Plum, studied neurology, and stayed there on faculty before coming onto faculty at the University of Iowa.
So how did you become interested in cardiovascular control, and who were the people that influenced you to do that?
Well, I'm going to backtrack a little bit, back to VMI. The person that I alluded to, his name was Robert Carroll. We all called Dr. Carroll Doc. DOC, Doc Carroll. And Doc was a phenomenal individual that would be worthy of an interview that would take more than an hour just to describe Doc. But one thing I'll never forget about Doc was that he taught us all that what's in books is only a tiny part of knowledge, and most of what's in books is already out of date. So there's much to be learned other than what's already written. Doc was very influential. When I went to the University of Virginia, I arrived there in 1966, which happens to be the same year that a fairly prominent physiologist also arrived at Virginia. Bob Byrne came from Case Western Reserve along with Nick Spirolakis, and much of the physiology department from Cleveland moved to Charlottesville. And if anyone was not stimulated by physiology before Bob Byrne, they'd have to be stimulated after Bob Byrne. And of course, cardiovascular physiology, and particularly cardiac physiology, was his baby. So how could I not be interested in cardiovascular physiology with Bob Byrne as a teacher? When I got close to the end of my medical school training, I spent a summer at the National Hospital for Neurological Diseases at Queen Square in London. And that was a very fortunate choice to have gone there that year, because one of the speakers who came to the National Hospital was Fred Plum. And he gave a lecture that, to me, to this day, was one of the most exciting medical scientific lectures I'd ever heard. And I thought at that point, if I get a chance to train with this fellow, this is where I want to go. So that was a stimulus, actually, in 1969 that really triggered me to look very seriously at Cornell. If I was ever going to have a chance to go there, I wanted to. Anyhow, I went from the Army or from Case Western Reserve to the Army. In the Army, I had another very fortuitous encounter with a prominent cardiovascular physiologist named Melvin Marcus, who preceded me to Iowa, but Melvin was the senior cardiologist for the cardiac intensive care unit in the Army, and I was assigned the cardiac intensive care unit. So Melvin and I worked very closely together. He taught me a lot of cardiovascular physiology. We became very fast friends. And after I finished my Army career, I went on to Cornell. I've already mentioned Fred Plum, who taught us as neurology residents that really to take care of patients, we had to apply scientific principles. And when we were at the bedside seeing patients, you could count on Fred querying you physiological principles with regard to the diseases that we were dealing with. And one day I came in to work, and my attending that had been assigned to our ward was a fellow that I really didn't know. His name was Don Reese. And Don at that time was doing clinical work as well as his already well-recognized science. And Don and we encountered a lady who had what's called orthostatic hypotension, a fall in blood pressure when she stood up. In fact, if she stood up, she would just faint. Straight out, she'd faint. And Don, in teaching us that afternoon, went to the blackboard and started tracing out what was known at that time about cardiovascular reflex control, the pathways and how they worked and whatnot. And I was just taken by it. I thought it was terrific. Well, anyhow, time passed and I began to get toward the end of my neurology residency, and I knew that I was going to have to go in the lab. Unlike you, I don't have a PhD. I've only got an MD. That was a conscious choice when I was at Virginia. Whether it was the right choice or not, I've never known. But I only had an MD. I'd never had any lab experience. And a good friend of mine, as a senior resident, said, well, go talk with Don Reese if you know him and see if Don has any advice about how you can establish your lab career. I did, and Don queried me and asked me, I remember very well, Bill, what is the thing that you found most stimulating, most exciting during your residency? Clinical situations, whatever. And I said, well, Don, I'll tell you the truth. The day that you stood at the blackboard and took us through the dynamics of the cardiovascular control through the nervous system, both peripheral and central, I said, that just really stimulated me. And he said, almost to quote, do you want a job? And from that point, we got a postdoctoral fellowship from the NIH for me. We went on to have projects together in his program project, and he stayed a very close and dear friend. I then moved to Iowa, and if Don Reese, I always thought of as my scientific father. If he was indeed my scientific father, I met my two scientific uncles when I came to Iowa with Frank Abood and Mike Brody. That's sort of it.
So back in those days, how common was it for a clinician to want to do science? And I know that was true at Cornell, but across the country, was that a common thing?
No, I don't know whether it was a common thing, or I really haven't studied whether it was more common then than it is now. I personally would think it a good thing for science and a good thing for medicine if more people who were engaged in patient care and devoted to patient care actually had a scientific background. I'd like to see more MDs in science, but I don't know what the frequency was. Out of my residency group, which was 6 residents, I think there were 3 of us who went into academic scientific careers, and 3 that went into private practice. So even at Cornell, which was a pretty academically oriented program, 50% of them went into private practice and 50% academics. That's probably a little higher than it is in some other places, but I don't know what the real statistics are.
So throughout your career, you've done a number of different things, but you've maintained a very common thread of studying central control of cardiovascular afferents and their processing in the medulla. What do you view as your most important contributions to science?
That's a question that actually always makes me a little uncomfortable, to be honest with you, because I don't personally think that I've ever accomplished anything, certainly alone. So anything that I might consider having accomplished has been a team effort. You know, when I was with Don, we were the first to provide the early data that subsequently led to the acceptance that glutamate, the excitatory amino acid, is a transmitter released by baroreceptor afferents. We've continued work on that since I came to Iowa and expanded that to show interactions between glutamate and other potential transmitter compounds, including nitric oxide recently. So I'd like to think there's a little bit of a contribution there, and certainly that's an area of research that's become quite prominent in other laboratories and in other countries around the world. So I'd like to think that we had a little contribution to that. I'd like to think that our contributions toward an understanding of neural control of the cerebral circulation, and in particular the autoregulation of cerebral blood flow, is something that will stand the test of time, and it's a little too early to know how well the test of time will be stood with our studies of astroglia, but we're very excited about the contributions that we have and can make to an understanding of how astrocytes are important for neuronal transmission in the brain.
So now another very important part of your career has been being involved in national policy issues and training of young people. And you've been heavily involved in animal care issues. Tell us about why that came about and what your role has been.
Yeah, well, I reckon in the way of thinking of contributions, one of the things that I feel most gratified in having had an opportunity and hopefully have made some contribution is in the area of public policy and trying to promote physiology specifically and science in general. I got into public policy and into the issues of animal care and appropriate humane use of animals in research, really for me almost by serendipity. In fact, by serendipity, I was working on the advisory committee for the Neurocontrol and Autonomic Regulation section here at APS, and they had me as their representative to what's called the Committee on Committees. And that committee decides who's going to populate the various committees of APS. And one day at a Committee on Committees meeting, they asked me to leave the room because they wanted me to be considered for chairmanship of the Public Affairs Committee. That's what it was called in those days. It probably was a foolish mistake on their part, but they did choose me to be the chair when I hadn't served on that committee. And I had to do a quick crash course on public affairs and on animals because animal care, humane use, regulation of animals was something that was very high on the profile of APS. Alice Ronan probably threw up her hands wondering what she'd been saddled with a person with so little experience, and Alice did a phenomenal job in teaching me both public policy and an appreciation of where we stood and what we needed to do to try to promote the humane use of animals. So I got into it not because of a long-standing interest in that area of public policy, but clearly an interest scientifically in being able to see that animals were used and used properly for us to get to the answers that we sought. I can't say it was something that really was so much by design for me. It was one of those chances that came along, and I hope I did something by contributing to it.
So in your leadership roles with APS and FASB, you've spent a lot of time testifying on Capitol Hill to the Senate. Tell me about how that has been personally and for your career.
Yeah, I'd have to say that probably in thinking about those testimonies and thinking about the very first one, and remembering how stressed I was, I had white knuckles. And then afterwards, realizing that the people with whom I was talking, the senators, the congresspeople, their staff, they basically got up in the morning the same way I did. They were interested in gaining information, and I was interested in helping them get information. And I viewed it as an opportunity for collegiality with our elected representatives. And I must say that I've found it always to be that type of relationship, so that it's one that I would encourage people to take an opportunity to do. It feels intimidating when you first start it because you sort of think, oh my word, I'm meeting with the senator. But the fact is that they are probably thinking, oh my word, I'm meeting with the scientist, because they don't know our language and we may know theirs better than they know ours. They're eager to learn, and it's our opportunity to help them learn what ticks in our world and what needs to be done to make it keep ticking. So I loved it. I mean, I'll confess it was a major part of my career I really enjoyed. So.
During the years you were involved in policy issues, what were the most important issues that came up that really shaped the field?
Well, a recurring theme has been funding. I can't remember a single time in testimony for APS or FASB on Capitol Hill where funding was not something that was a concern. We think nowadays about how bad funding is, and it is, but funding has always been a concern, and trying to see that we could get a steady and appropriate and not undulating budget has always been a concern. So that's been something that we've discussed. Depending upon the year and what was high profile at the time, animals have been very high on our agenda for APS. Sometimes similarly for FASB, they've been a very high topic of conversation with our representatives. Recently, I'd say that issues of reproducibility are issues that all of us in science are concerned about. It is a scientific issue, but it's also a political issue. If we in science cannot provide data that not only can be reproduced, but can be taken for the betterment of man or animals, humans or animals, then the question gets asked, why are we paying for this? And that's the public asking the question. So we share a lot of common themes, the politicians and we scientists who advocate, and whatever the issue is of concern, sometimes they are political profile issues. That's going to be what we discuss. So it's not always a single target. It's never a single target. It could be anything that might be on their radar.
So you mentioned funding and reproducibility. What do you think the biggest changes have been over your career in the scientific field and in development of people's careers?
Yeah. Well, I'll answer that as an MD, first of all. When I graduated medical school, in almost total part because of the economy, my being able to get a job during the summer and help pay for my medical school training, but also because of a devotion on the part of my parents, I graduated with next to no debt burden. Nowadays, it's more common than uncommon for a medical student to graduate with a six-figure debt burden. That has to be put into the context of career choice. For me, I had found a passion. I love science, I wanted to do science, and nothing was going to get in the way, okay? But I didn't have a six-figure debt burden to consider. I was very fortunate that I had things fall into place and I could get into science, but I could very easily have made a choice to go into clinical practice and enhance my income greatly by doing that. But the passion was there, and the passion was to have science as part of my career. And I'd say that that's not unlike even our graduating students now. They have to have, it doesn't have to be going into science. Whatever you go into, you've got to go into because you love it, not because you think that you're going to get a certain amount of money out of doing it. And for me, I made the right choice. Turned down a job in private practice, which would have paid me 2 or 3 times what I was making at the time, at the very beginning. And I think medical students nowadays have that opportunity, but it's a little bit more challenging because of the debt burden that they face. There have been other changes, though, as well. Stop and think about what's happened even in the past 15 years. I mean, we've gone from a world where most everything is in print to a world where most everything is electronically communicated. We've gone into a world where anything that happens, whether it's something that it's a good discovery or something that you've done that's a little shady, not the way it should have been done, ethically, maybe, whatever, into a world where what we produce may not be reproducible or it may not be translatable in the speed of light that is transmittable all around the world. Okay, Twitter and Facebook and this, that, and the other are things that I didn't even know how to spell when I was younger, okay? So we have to face a reality that we're living in a world where what we do and the way we do it is shared instantaneously around the world. And that makes our obligation all the greater. It's something we didn't even conceive of at that level of communication when I was coming along.
A lot of the things you mentioned in terms of having to have a passion for science and having to make a choice between greater income versus doing something that you might want to do more. They sound very similar to what the choices are for young people today.
Absolutely.
And I think that people are concerned about funding, and rightly so. How have all those things, do you think those factors have changed substantially in your career, and do you think they're different now for a young person than they were for people?
It seems to me that at least for the MD, the debt is probably greater by the time they finish their training. I can't relate to that very well because, as I said, I was fortunate not to have graduated with great debt. I think that the The funding opportunities are more difficult to achieve now than they were, historically, than they've ever been. I fear that the people who could and would go into science, typically pretty bright people, realize the relative risk of going into science with regard to stability of career, and they may choose other careers, other areas of endeavor. But I also am optimistic enough to think that we're living through a short-term downturn and that science will begin to be revered as it was in the Kennedy era, and as we developed a budget that promoted science, and science was a hot topic and kids wanted to go into science, that will once again come back to being able to have opportunities and people recognizing them and coming into them. So I sort of see it as a phasic thing. I hope that answered your question.
Yeah, that's sure. Very good, actually. The other question is always about whether or not MDs should be doing science, whether or not they're making, if the investment in, for example, MSTP programs by the NIH has been worth it, whether or not the new investments by some of the NIH institutes for training physicians to do research during their residency, whether or not all that investment is worth it, because it's first of all, the question is that really where we want people to be doing research? And the other is many people who go through those training programs don't actually end up becoming physician scientists. What do you think? Yeah. You yourself are a physician scientist, although you didn't do a PhD. You're very much a physician scientist and followed the kind of the model that used to be followed when you were younger, where you go to just an MD. But how important do you think that is in terms of our treating diseases, understanding physiology?
I think that question is asked very often, and it's one that's, I think, often answered from the bias or prejudice of the person who is sort of asking it. My own view is that we as a country are much better off having as educated a population as we can. I think we as a potential population of patients are better off if we have doctors, physicians, who not only are caring people in the sense of truly being caring, but also providing medical care. But if those people are able to scientifically, critically analyze, determine what's a good study versus a not good study for the use of a new drug that may be something that would be used for disease, we're better off having someone who's trained in science, even if that person may never step foot in a laboratory again. When I was the president of FASEB, we had a long discussion on this issue with regard to, are we training too many people in science? Is it worth the federal dollar, the American public's tax dollars, to train people in science when there's relatively this number of jobs and relatively this number of people to go into them? And my feeling always has been that even if we spend tax dollars to train someone to have a PhD, and even if that person never again does a laboratory experiment, that person is able to be a better teacher in college of science curricula, to be a better analyst of what they need to understand to be able to make decisions. How could anybody argue against education? I mean, so I just view it as sort of the end point, the graduate degree, without an implication of a particular job that person has to hold to be a success in getting that degree.
Is there anything that you think can be done to encourage young trainees to continue in a career in science, especially if they're physicians?
Well, I think there's two things. One I've already alluded to. I think we need to have the opportunity for a stable career. People would like to be able to look into a career where they can see a future and have, even if they don't want to make boatloads of money, just a modest income, but still be able to make an income. People want to be able to do that. But I think it's vital, particularly for those of us that have gray hair, you included, it's vital for us to mentor the young people. We mentor, I think, many times quite well in terms of the scientific discipline and in the laboratory. But the mentorship goes beyond just teaching a person how to do science. I mean, there's all sorts of things that go on in life that we can provide our own experiences and mentorship outside the laboratory. It's one of the reasons that, quite frankly, I encourage young people to join societies. I mean, to join society like the American Physiological Society, or the society that fits best with the theme of your scientific interest, so that you have other people to talk to, learn from their experiences, learn also from, you know, the pits and valleys that they've experienced. We can help in that way, those of us that are already in it.
So wrapping all that together, what advice would you give young people today?
Well, you're asking about what advice for somebody going into science or thinking of going into science, but I think it's the same advice that I'd give to a young person regardless of what they're going to go into. And that is find something you really love. You know, find something that makes you want to get out of bed in the morning. You know, there's no sense in making a choice toward any career. Science is one that requires a lot of devotion, but then every career requires a certain degree of devotion to be able to justify waking up in the morning and going in. And if you're going to have an opportunity, you have to be reasonably intelligent to get a PhD. You have to be reasonably intelligent to get an MD, okay? And reasonably intelligent people have lots of choices, okay? So making the choice that's going to be your career choice really needs to be based upon the thing that's going to provide interest to you for the rest of your life, because it's a sort of lifetime choice.
You mentioned security as being an important part of
It is.
what will make people want to go into science. But of course we're in a field that is competitive, and it always has been that way. And so how do you feel things have changed in terms of security? If somebody wants to go into science, is there something that we could do to make it more secure?
Well, advocate to Congress that we have better funding so that the pay line at the NIH is a better pay line. That would provide a little bit greater, nothing is going to provide a guarantee, but that would provide the potential for, greater potential for continued funding. When you look at the age of a person's getting their first R01 being in the mid-40s, and the chances of having the second R01 being not so great, it makes one look at the career not so sure. I think that there are things that need to be done at the NIH level, both to get young people into science, but also to bring them along so that they can be highly competitive when they go in for that second R01 and third, and then they can continue their careers that way. And that's not just pouring more money into it, that's making sure that the people that get into it are really, really competitive and doing really, really the type of work that we as an American public would hope they'd be doing. I don't know whether I'm addressing your question, or maybe I should say, do you have an answer?
No, I don't have a specific answer. I think it is important for people to realize that that it needs to be competitive in order to make public funding be used wisely, and that there probably are many avenues for people to go to follow the careers in which the experience that they've had in the lab will still help them. For
Absolutely.
example, being a physician. And so I keep reminding people that if you fail in science and you have an MD, you can double your money, double your income by going into practice. And yet that training may have been very valuable. And there's teaching roles.
Absolutely. That's a smaller population, though. If you think of the people that have gone into science and gotten a PhD, but don't have another postgraduate degree. And what happens to that individual if they don't continue to get federal funding or any funding for their research? What I said earlier, I really mean, and that is there are plenty of other opportunities, other careers for those people to be great contributors, whether it's in teaching young people science, and who could be better at teaching someone science than someone who's practiced it, okay?
Right.
I don't view people who don't ever get federal funding or get it and then can't get it again as a failure. I view those people as having an opportunity, and for us as a society, having an opportunity for them to do the things that they can do that are really quite unique, more so than the general public.
Yeah, I guess like working for pharmaceutical industry, medical writing,
Sure.
and consulting for companies. Those are all options that I know people
And
take.
public policy advocacy, working with Congress. There are people on Capitol Hill who work as staff members to elected members of Congress, advising them on science, advising them on science policy. The people in whatever Democrat or Republican administration that do the same thing. And that goes all the way down to the local level. There's ample opportunities out there. I really believe that the more and better education that we as a public can have, the better we are as a public. So I don't see any loss or harm to that.
Okay. So how does this meeting of the APS this year differ from the ones that were the first ones you went to?
Well, the first one I went to was the FASEB meeting. Okay. It wasn't called EB in those days. That evolved into EB, but it was the FASEB meeting. And my recollection, perhaps just because I was young and naive and it was amongst the first meetings I attended, my recollection was that it was huge and it was impossible to negotiate. My recollection is it was like 30,000 scientists. Now that's, unfortunately, in my view, what has evolved for another society. I belong to the Society for Neuroscience, where now the meetings are unwieldy and impenetrable and huge numbers of people. So to my view, we have in EB and in the APS parts of EB a more manageable meeting where we need to be sure that we have the various physiological disciplines represented, so there's a cadre of people that can act as the network for other people within those thematic areas. But I find it at this meeting now not so unwieldy, a place where the work that we do is received well. I get feedback from it. I get to meet with people who are in the similar area and somewhat divergent areas. For young people, if they're going to get advice, learn how to network and learn how to do it early because you can't do everything on your own. You have to meet other people with whom you collaborate. I mean, it's goodness gracious, you've even bent down to collaborate with me on some future work that we're doing. So I think that coming to a meeting like this now is just a golden scientific opportunity. I frankly think it's better now than it was before, but as I said, my recollection was that before FASEB meetings were much bigger, and now they are a bit smaller and a little bit easier to get around.
So I guess you alluded to it a little bit, but what do you think the APS has done to contribute to your career?
Well, it provides a home for my science. It provides, through its journals, a home for publication of data that we create. But without question, APS, tipping my hat to Marty Frank, the executive director, has made a real effort to be a society that is open for the participation of its members. If someone in APS wants to work within, to provide their ideas, to share with others who have like ideas, and to bend the ideas toward ways that they're thinking, APS is the place that has been welcoming to me. It gave me an opportunity to learn some things about public policy, to get engaged. I never could have been FASEB president if it hadn't been for the opportunities that APS gave me. It gave me opportunities to participate on the ALAC board. Now I sit on the neighbor board. Those are opportunities in terms of public policy and a different career twist that I never ever would have had if it hadn't been for Marty Frank and for APS. And if it hadn't been for Alice Run-On in APS, who probably still is throwing up her hands wondering whether she ever taught me anything. I learned a lot of public policy from the people who were experts in public policy in APS and subsequently in FASEB. So, I mean, it's the society for me, and I can't say enough about it. Of course, all of us think of it as a scientific society, appropriately so, but it's more than that. You know?
So speaking of public policy, you've played a very important role in trying to reduce the regulatory burden on scientists, and you know, that's something that's become a big issue for both medical practice and for scientific practice. What do you view as the future of that issue?
I wish I had a crystal ball. I'd like to think that we, both as a civilian and a scientific public, would be able to come to grips with what is necessary regulation versus cloning of regulation so that it constantly gets more and more. I don't need to tell you, because you're in a position of authority and administrative levels within our own university, but many times we as scientists view regulatory burden as coming from on high, from the federal government, from state government, when some of it is created out of our own devices. It's created from within our own institutions. It's created because of a concern of having to stay ahead of what the regulators are telling us we have to do, so we never get in trouble with what they might tell us we have to do. So there are things that we can do working together within our own institutions. Now, that requires us scientists to get off it and to participate in those groups that make the regulations or interpret them. Scientists must be involved in their IACUCs, they must be involved in their IRBs, they must be involved in their institutional administration to be sure that we don't live in a constantly defensive mode, but we can actively see that appropriate regulations are appropriately interpreted and it doesn't provide any more burden than is absolutely necessary. But I have seen relatively little indication that we're doing that, and that's a little depressing.
So do you have any closing comments for the people that are watching?
Really just thanks for getting me through enough years to be able to be here to have an interview. It's a real pleasure when I look around at other people who've already given these interviews. The things that I've seen and looking at the interviews that others have given were like going to school for me, and I hope people find even a small part of what we've discussed today of any value to them. Thanks very much for doing the interview, and as I said before, thanks to APS and Marty et al. For putting these things together.
Well, thank you, Bill, for participating.
Pleasure. Thanks, George.
And really enjoyed learning more about you and your career.
Thanks a lot. Thank you.